Hello guys, today we will prove several properties of logarithms and in the end of the video we will see several applications. At first, logarithm definition is that log AB equals x, it means that a to the power of x equals to b. Log AB to the power of n equals n times log AB. This is the first formula, and we can easily prove this if we imagine that a to the x equals to b. So if we take both sides into n power, we will get a to the n times x equals to b to the power of n. And log base a, b to the power of n, this is equivalent of log base a to the power of nx, which is clearly n times log of a to the ax, which is exactly log of ab. So we prove the first one. In the second one, if we assume that log AB equals x and log AC equals to y, this means that a to the power of x equals b and a to the power of y equals c. So b times c will be a to the power of x plus y. And if we consider log ABC, this can be written as log a to the power of x plus y, which is exactly x plus y. X equals to log AB and y equals log AC. So we prove the third one. Here we can prove this. Okay. Clearly the third one is almost same as second equation, but the difference is that if we consider b over c, this one equals a to the power of x divided by a to the power of y, which is clearly equivalent of a to the power of x minus y. And if we use this substitution, this will be equivalent of log base a times a to the x minus y, which is clearly x minus y. And clearly this is x part and this is y part. And we are done. I think next easiest part is lemma 6. In lemma 6, as we know that a to the x equals b, and if we take both numbers into n power, a to the nx will be clearly b to the power of n. So if we want to take a to the n in x power, we will get exactly b to the power of n. So the logarithm of base a to the power of n of b to the power of n will be clearly x. And as we already defined that log ab was also x, we are done. Now let's prove lemma 5. In lemma 5, once again, assume that log ab equals x and log ac equals to y. In this case, log ab divided log ac, this can be written as x over y. We know that a to the power of x equals to b, and a to the power of y equals to c. And if we want to compute what is log base cb, this is equivalent of log a to the power of y to the a to the power of x. And clearly, we need to take, if this equals to k, this means that a to the yk equals a to the power of x, which clearly means that yk equals x, and k will be x divided by y, and this is exactly what we wanted. It's equals to k, and so this is also x over y. And we are done. And for the fourth equation, I think this is the hardest one. And for this one, we can apply lemma 5. And in lemma 5, if we apply lemma 5, we get log a base ab divided by log base ad. This equals to log base cb divided by log base cd. And by using lemma 5, this one equals log base db. And similarly, the first one also equals the same thing. And clearly, we get the equation, which is always correct. These six formulas are the main formulas which can be applied in any logarithmic equation. Logarithmic equations are very popular for the multiple choice Olympiad like AMC and AME. And now let's see several applications. In the first one, here we are given logarithm of fractions. And if we use the formula of log A over B, generally, if we don't have any base in logarithm, this means log base 10. Log A over B equals log A minus log B. You can see that this was the third formula. And if we expand like this, the first one will be written as log 1 minus log 2. Second one will be expanded like log 2 minus log 3 and so on. Plus log 4 plus log 3 minus log 4 and so on. And final term will be minus log 100. We can see that all of the terms will be crossed out except the first one and last one. Answer will be log 1 minus log 100. And as we know that log 1 equals to 0, this will be negative log 100, which is exactly minus 2. And final example for about logarithms is a bit hard one. And for this problem, we will need some arithmetical properties. I call this lemma one of my top students' lemma, Mirza's lemma, because he was using this one very useful, like very often. In this case, a over b equals to c over d. This fraction can be also rewritten as a plus c divided by b plus d, or similarly a minus c divided by b minus d. We can easily prove this if we take cross product. For example, if we know this means that AD equals BC. And if you want to show that this fraction is still same, if we take cross product, we will get CB plus CD equals AD plus DC. As DC part cancels, we will get AD equals BC, which was our assumption. And how can we apply this in logarithms? Generally, when we have different base logarithms, it's always better to rewrite them into one base log. So the first one can be substituted as log p divided by log 9 is equals to log q divided by log 12 and equals to log p plus q divided by log 16. And here we need to guess that 12 square equals to 9 times 6. 9 times 16. Sorry. And once we guess this lemma, sometimes if we are able to somehow add these two equations to each other, we can imagine this is A, this is B, this is C, and this is D. And if we use Mirza's lemma, we will get log P plus log P plus Q divided by log 9 plus log 16. We will get this equals to log Q divided by log 12. And log 9 plus log 16 by our formulas will be log 144, which is 2 times log 12, as it is 12 squared. So our equation can be rewritten as log p times p plus q. Here we are using second property, and bottom one will be 2 log 12. Here we can easily see that if we take cross product, log 12 part cancels and we get 2 log q equals to log p times p plus q. 2 log q, this is just log q square, and this equals to log p square plus pq. And if logarithms are same, clearly this means that numbers are itself same. So q square will be p square plus pq. And if you look at the question asks, what is Q over P? In this question, it's impossible to find P and Q itself, but their ratio can be found. So if we arrange all of the terms in one side, we will get 0 equals there's Q over P. So Q square minus P square minus PQ. And if we divide everything by P square, we will get 0 equals Q over P squared minus 1 minus Q over P. And if we assign Q over P as x, we will get 0 equals x squared minus 1 minus x. And clearly this is quadratic equation which can be easily solved. So x will be 1 plus or minus 1 plus 4 divided by 2. And clearly this will be 1 plus or minus root 5 divided by 2. And the answer will be only 1 plus root 5 divided by 2 because x and p and q must be positive numbers. And 1 minus root 5 divided by 2 will be negative number. So if you have any questions about any properties of logarithms, please write in the comments and I will try to clarify it. Or if you have any questions about them, feel free to ask me.